Earth's tiny orbit is a busy place, with thousands of objects measuring more than a few centimeters across, swinging around Earth, and millions of smaller bits around the size of flecks of paint. Inevitably, the International Space Station gets hit by micrometeoroids now and again. There's a lot of space junk around Earth for the International Space Station to avoid. Some of these orbital debris are human-made objects that don't serve any useful purpose, like used rockets, retired spacecrafts, and fragments from re-entry. Just last week, ISS powered up its thrusters to avoid a debris from a Russian anti-satellite missile fragment that was likely to hit ISS. It's likely that such close calls will only get more common as humanity keeps cluttering up the space lanes with old satellites and wreckage from collisions and missile tests. It can be an extremely tense situation up inside the station for astronauts working inside ISS, as lives are at stake, and if things go wrong, help's not on the way. While the size of the ISS is really impressive, it also makes it a big target for numerous pieces of space debris in orbit, so here's how NASA and astronauts dodge the space debris in real life, and what'll happen if it actually gets hit. You might have seen astronauts piloting ISS like it's the Millennium Falcon in Hollywood movies, but in reality, nobody sits in a cockpit on the ISS with a joystick turning the whole station left or right out of the path of an incoming chunk of debris. That's not how space maneuvers work. Instead, if you're on a collision course with an object in space, you either speed up, which boosts you to higher orbit, or you slow down, which puts you into a lower orbit. And all of this is done from the ground-based mission control team. To dodge last week's Russian anti-satellite missile debris, a Russian Progress cargo ship was docked at the ISS and fired its thrusters for about 5 minutes, which boosted the ISS into an orbit a little less than a mile above its old one. A few hundred miles away from ISS on the surface of the Earth is Mission Control Team, who schedules these kinds of maneuvers in advance. It takes a few weeks for Mission Control Team to calculate a new trajectory, as they must figure out what's the safe orbit, how much thrust will it take, is the new trajectory in the path with any other existing satellite. This process is called Predetermined Debris Avoidance Maneuver. It's good for us if we find the space debris months earlier than collision, but what if there isn't enough time to plan for all these evasive maneuvers? If you watch sci-fi movies, you might have heard the phrase, brace for impact.
All hands, brace for impact!
Well, it's not exactly what happens inside international space stations, but a crew inside ISS do prepare for possible emergencies. This means they have to round up important items and close the hatches between pressurized sections of the station so that if one module is damaged, it won't depressurize the others. Just few hours before possible impact, all crew must make their way to docked spacecrafts that will be their ride home if ISS is damaged beyond repair. If the damage is minor, all the astronauts inside ISS are trained to repair it. Now, moving on, let's find what would happen if something actually hits the ISS. One of the notable impact events include an incident in 2012 when a small meteorite struck the window on the ISS cupola module. An emergency shutter was automatically pulled over the window to prevent any loss of pressure to the vacuum of space in the event of leave. But the damage wasn't serious and no leak was found, so the shutter was later removed. According to NASA, most of the crew compartments and pressurized tanks that make up the International Space Station is able to withstand the impact of debris as large as 1 centimeter in diameter. This almost covers a million tiny bits of screws, paint flecks, or stray hardware floating in space. If you're thinking, how can a debris less than a centimeter damage the ISS? You know how small a bullet is, but it can do a lot of damage, right? The point here is not the size of the object, but the speed of the object. Up in space, when a small projectile that travels at 10 times the speed of a bullet crashes into the ISS, it can really wreak havoc. If debris actually hits ISS, astronauts could safely get back to Earth by getting into Soyuz capsules. But if the impact is something like a meteor that exploded over Chelyabinsk in 2016, that's something nobody on the ground saw coming. If by some terrible chance it hit the ISS, it would be a full-on disaster, and very unlikely for anyone inside the ISS to survive, unless they somehow get into their Soyuz capsule immediately. Including last week's maneuver, the ISS has shifted its orbit around 32 times to dodge a chunk of space junk or a dead satellite. That's about 1.5 evasive actions per year since 2000 on average. However, NASA said the actual frequency varies. For example, ISS had 9 maneuvers in the year of 2014, and 15, and then had 0 until 2020. At the moment, there are about 9,000 metric tons of space junk orbiting our planet, ranging from paint flecks to whole satellites that have run out of fuel or stopped working. And worst of all, we keep adding to it. This happens when space agencies or private companies don't arrange their satellite to fall back to the Earth's atmosphere to end their life. Normally, debris comes from when 2 satellites collide, or when rocket stages, or when the whole spacecraft blows up. Or it could also be from when a country intentionally blows up its own satellite to demonstrate that it has the power to blow up somebody else's satellite. That's exactly the kind of test that destroyed Cosmos 1408 satellite, forcing ISS to keep dodging bits of debris for several years. Countries like Canada, Germany, Japan, New Zealand, South Korea, the UK, and US have banned such anti-satellite missile tests. At the moment, space debris are not that big of a problem to us humans, but in the future, it may be the very reason to lock us within our own planet. Back in 2019, an Indian anti-satellite missile test created a huge cloud of debris, but most of it burned up in Earth's atmosphere within a month of the test. On the 27th of March 2019, Indian Prime Minister Narendra Modi announced to the world that India had conducted its first successful anti-satellite test, launching a 3-stage missile from northeastern coast of India with a trajectory taking it over the Bay of Bengal. It was on a collision course to military satellite Microsat-R, which was 283 kilometers overhead. The test shattered the satellite into hundreds of pieces. The test was universally condemned. If the problem continues to grow as our space activities grow, the potential loss in money from those collisions and chain reactions it could cause in a busy Earth orbit is gonna motivate big countries to fix the problems. And not only is the cost of the satellite that'll motivate the efforts, but the entire economy has also been built upon the services they provide, like GPS and the internet. Treaties dictating the space operation should be modified to mitigate the issue, ensuring any satellite placed into Earth's orbit will be required to be capable of bringing itself out of orbit and be capable of dodging debris when required. On the bright side, scientists are already experimenting different ways to get rid of the debris. One of the most promising technologies will involve using a high-power laser that will be powerful enough to ablate material from the object, which will slow it and eventually fall down to Earth's atmosphere where it burns out to nothing. However, there are issues with technologies like this, that it could be used as an anti-satellite weapon, which would not be good news for other spacefaring nations. To overcome this, it would need to be a joint venture between all spacefaring nations. Just as International Space Station became an international effort to unite mankind, clearing out debris should be the same. We hope you learned something from this video, and do your bit by sharing this knowledge to your friends. If you love what we do here at Astrophy, please subscribe to us and hit the bell icon to be notified about our new videos. And lastly, thank you for watching the video. See you next week in our new video.